Let's get started then. My name is Oleksii Petrov and I'm Solutions Architect at Jain Irrigation. And today we have a very special guest for our Q&A session. Welcome, Neal Ford. This is a man whose accomplishments are hard to list or exaggerate. Neal is a director and software architect and meme wrangler at ThoughtWorks. He is internationally recognized expert on software architecture and development. And he has authored numerous magazine articles, dozens of video presentations, 9 books, with my personal favorites such as Software Architecture, The Hard Parts, and Building Evolutionary Architectures. So he has spoken at hundreds of developer conferences worldwide. And now we have him here at our conference in Ukraine at fwdays'23. Neal, we would have a huge series of applause right now if we were offline, because you are absolutely superhero in software architecture of mine and many developers and software architects I know in Ukraine.
Well, thank you so much.
Have you here today.
Thank you so much for the kind introduction. It just shows that what appears to be superpowers is really just, keeping plugging at it for a long time. So,
no, I don't want to agree with that, because I really think that you're moving architecture thought forward for many, many years, and I can't overrate your accomplishments and things you've done for community. I'm very grateful to you for everything you do, for all of your books, for all of your events, for all of your workshops, for all of your talks. Everything is highly appreciated in the community and has a lot of value in it. So thank you so much.
Well, that's actually very much on purpose, because when I joined ThoughtWorks, that was in the very early days of the Agile software development movement. And part of what we had convinced clients was, should we even do this Agile thing? But there was a big debate at that time about, do we need software architects? If we're Agile, software architecture seems like big planning up front, and we're trying to get rid of that. So should we even have architects? In fact, when I was hired at ThoughtWorks, I was hired as an architect, but then one of the first people I met, they said, "Oh, what's your role here?" And I said, "An architect." And they immediately said, "We don't have architects at ThoughtWorks." I said, "Oh, really?" And they said, "We have tech leads, but we don't have architects." But I realized very quickly that there are some things that we call architecture that are really beneficial to do on projects. The real trick is, how do you adapt it to the Agile software engineering practices? How do you build feedback loops? And so I've been on sort of a mission, along with a lot of my colleagues at ThoughtWorks, to kind of adapt the idea of architecture the way it used to exist in a way that makes a lot more sense in the modern world. And we were definitely all benefited by microservices coming along and being something that people recognized as, hey, this is a true business benefit, this architecture thing they're talking about. And that really, I think, promoted the role and influence of architects a lot more because of that.
Yeah, sounds perfect. And we'll talk about that a little bit more during the Q&A session, because I've gathered numerous questions from the audience, and there were some regarding the topic you touched on, but we will get back to this a little bit later. First things first, I just wanted to ask you the thing that is on your bio, and I think it catches an eye, like when everybody reading it, because it has a nice ring to it, like meme wrangler. What does it even mean, a meme wrangler? Could you please explain about that?
Sure, I get that question a lot, and that's part of the reason it's there. But ThoughtWorks is one of those companies that allows you to create your own title. I mean, you can't choose, chief scientist or something like that. Martin Fowler already has that, but you can choose within a reason. So I've met someone at ThoughtWorks whose title was seat warmer, because they, don't give their business card to many people. And so my first round of business cards at ThoughtWorks had application architect on it. But then I realized, exactly appropriate to my story before, because that was 18 years ago when I joined ThoughtWorks. So 18 years ago, the title application architect in a lot of organizations meant post-useful. It meant that you spend a lot of time with diagrams, and the ivory tower archetype really came from there. And that was a negative inference. And so I was looking for a new title for my next set of business cards. And I actually thought meme herder would be interesting. But then I was on a mailing list, and I put that suggestion out there, and Prag Dave Thomas was also on that mailing list, and he suggested Wrangler. And of course, Wrangler has a much better sound to it. But it's
Yeah.
one of those weird self-fulfilling prophecies. I mean, this is before the idea of an internet meme really was popular. But a meme is a viral unit of thought, and a meme wrangler is somebody who gathers those up and then wrangles them, herds them somewhere.
Yep.
And in many ways, it's kind of a self-fulfilling prophecy, because you can look at all the books that I've written as memes that I've wrangled. In fact, I put on social media after one of my books came out that another meme wrangled, and then the colon and the title of the book, because it's sort of what I've ended up doing professionally, sort of accidentally. So it became a self-fulfilling prophecy.
Meme wrangled. I like that one. It's like myth busted, Something
exactly.
Like
yeah, exactly.
Perfect. Thank you. Just a short intro about the audience and the session we're having today. So, like, our conference is software architecture conference for sure, but the audience of the conference is diverse. So we have here developers, we got team leads, we got tech leads, we got people who are just passionate about architecture and want to become an architect. And I wanted to structure this session from basic questions, maybe then going into the deeps of software architecture a little bit later during the talk. So, and for starters, I just wanted to ask, like, whether you have your favorite definition of what software architecture is.
That's a really tricky thing, actually. We sort of avoided that question in our Fundamentals of Software Architecture book. But as some of you may be aware, Mark Richards and I and Raju Gandhi are currently working on Head First Software Architecture, which is a little bit more basic book. And we've had to address that question a little more head on. And like so many things in software architecture, there's no hard and fast definition of architecture, but some of the things that are, I would call architecture decisions, are things like, what is the impact of trying to change this decision later? And the more impact there is, the more architectural that decision is versus design. Because you think about the opposite end of the spectrum, let's change it from a monolithic architecture to microservices. Massive impact to many people over months and years. That's an architecture decision. Let's change the color of the buttons in the user interface. That'll take one person 2.5 minutes. That's design. That's the opposite ends of the spectrum. And so, all of these things fall in somewhere in the middle. So difficulty to change later, what overall impact it may have on your project or other projects, like integration points and those sorts of things, and the amount of effort it's going to take to implement it. The other way to think about a definition of software architecture, because in our fundamentals book, one of the things that we wanted to do as we wrote the book was to try to figure out if we could come up with a few things that seem universally true across all architecture. We're hoping we come up with like 10 of them, and we managed to come up with 2, which we codified as these laws of software architecture. And the first is that everything in software architecture is a trade-off. But that's the thing that distinguishes us as software architecture. And you can almost bend that into the definition that says software architecture decisions are ones where each possibility has significant trade-offs. That's what makes it difficult. And that's what makes it an important decision, because those significant trade-offs mean, well, that means I get some things, but I don't get other things. And that's the essence of things that are hard to change later, or things that put you in a distinct direction that's hard to change in another direction. And the bigger the trade-off, typically the bigger that transition is. So that to me seems like the software architecture, a definition of software architecture.
Thank you. But not all the companies have a dedicated software architecture on a project, right? So sometimes that role is picked up by one of the developers they already have. Is there
I would argue they have software architecture on the project. They just don't have someone with that title.
Okay, so let's dive into this. Like, is a software architecture a role, a job, or a skill? So I think you're leaning towards a skill or a role, but what's your thoughts?
First and foremost, it's a role on a project. Any developer who makes a long-term decision that has significant trade-offs, I don't care what their title is, that's an architecture level decision. It's about the essence of the decision, not the person or their arbitrary job title who made it. I mean, the CTO may be not technical at all, and they may make a significant architecture decision, saying, for example, we're moving everything to the cloud. That's a massive architecture level decision, but that's, they don't have the title or role of architect. So it's very much a role. And in fact, we talk about a lot of the content that I do for O'Reilly, we target at this role that we refer to as the accidental architect. It's someone who makes architecture decisions, but they don't have the role or the title. They don't consider themselves that, but they are. And so it's very much, it's really about, again, I would go to, is this an architecture level decision? What's the impact? What are the trade-offs? What are the long-term, how hard is it going to be changed later? It's no matter who makes that decision.
Yeah. And actually, you mentioned this next question briefly in your introduction talk and at the beginning of this call. So about the architect term and architect definition, because I know that we've had some winters and summers for this architect job. At some point, software architecture had a bad connotation, as you mentioned. And I think with the rise of clouds and probably microservices, we went to in spring and maybe a summer for this role, because suddenly everything became distributed, scalable, elastic, or at least wanted to be so, right? So what are your thoughts about that? Where are we at that season circle? Are we still in summer? What are perspectives for the architect role and job?
Well, I like the characterization of seasons. I don't like the implied cyclical nature of it, because it doesn't mean that we're, eventually going to enter a winter of architecture again. I don't know that it's necessarily cyclical, but I do like the idea of the winter and spring idea. The question becomes, are the questions we have to answer, the trade-offs we have to evaluate, are they going to become easier in the future or more difficult in the future? Because that's basically what you're asking. I think they're going to become more difficult, because it seems like we're trading off more and more things. And, so I've always said that one of the reasons that the skill of software architect is valued in companies is that there's no such thing as a generic software architecture. Every architecture is this unique snowflake of combinations of this thing and that thing, and things we love and things we hate and things we have to integrate with. And we're not even sure what that thing is, but we're supposed to keep it alive. So I guess we will. We don't know if anybody uses it or not. That's software architecture. So, being able to do trade-off analysis in those kinds of unique environments is a really hard-earned skill. And I think that's going to be around for a while. And I don't see that diminishing anytime in the future. In fact, less so than a lot of other roles, which is, I'm sure the question is going to come up inevitably, but for all the AI stuff, which is really about automated knowledge, but we can't automate wisdom. And the ability to do trade-off analysis is the essence of wisdom, which is why you can't. So Mark Richards, who my co-author, very famously said when talking about structural design and software architecture that there are no best practices in software architecture. And that's an interesting statement, but it's true, because think about the idea of a best practice. A best practice means anytime this comes up, I can just turn my brain off and automatically do this thing because it's a best practice. It's not even a better practice. It's the best practice. So, that brooks no argument, but there's nothing like that in software architecture because every ecosystem is unique. I talk about this when people say, I'd really like to be able to download a tool that does this thing in my architecture. It's like, okay, well, how many people, first of all, have the exact same architecture you have? And then they have the exact same problem that you have, and then they fixed it, and then they took the time to write up a nice blog or something like that, describe it. It's, the circle is getting really, really small here for that overlap. So I think that ensures that architecture is going to be around for quite a while, because I don't see the trade-offs getting any easier.
I absolutely love that statement that there is no best practices in software architecture. It's a bit of controversial statement and catchy, but I really love it.
Well, when Mark first said that, he just said it broadly, and people rightly pointed out that there are some process things, like always evaluate trade-offs.
Yeah.
That's a good idea. But the structural design part, I think, and actually Mark and I have argued about this at great length because we've tried to find exceptions to that rule, but we keep coming back to the structural design. There's just nothing you can turn your brain off for. You have to get good at evaluating trade-offs.
Yeah, but this leads me to another question, what is a good architecture then, right? What does it mean to have one, good architecture, and how to measure whether the architecture is good or not?
Well, again, you can't make evaluations about generic architecture because the first question I would pitch back to you is what makes the architecture valuable to your organization? Is it the reliability? Is it availability? Is it the scale? Is it elasticity? Is it data integrity? Because that's the thing that makes it a good architecture or not. Now, if you just want to evaluate things like the internal structure of the architecture, how good the coupling is, how good the modularity is, how good the cyclomatic complexity is, how good your normalized distance from the main sequence and other kinds of metrics are, and that's one kind of evaluation, but you can build a perfectly pristine architecture that doesn't deliver much value to a company or an organization. So, it's like a really beautiful building that no one ever goes in because it's in a bad neighborhood or something. The architecture is beautiful, but the building is not useful. And so, I think that's where that's the only way to truly value an architecture is it delivering value to the organization that it's designed for?
Yeah, I get it. I get it. However, I want to stay a little bit in this topic. In the code development, in the writing code, we have things like code smells, right? So we have defined anti-patterns of code that we define as a bad code, and we want to eliminate that. And our checks of code, like goodness, I don't know if there is such a word, is validate whether we have or don't have those smells in the code. Do we have something like architecture smells?
Oh, certainly. So there's no way to determine universally if an architecture is good, but there are lots of ways to determine if it's bad. When, it's when it's unreliable, when it has, deficiencies all over the place, when it doesn't meet the service level things it's supposed to meet, when it's brittle. That's one of the things we talk about in the evolutionary architecture world is, of course, I'm a consultant, so I get to see a lot of broken things. But we had a client who had taken one of the tables and opened it up to their integration architecture as an integration point for convenience. And then they would change one datum and 15 systems would break. And they're like, what's going on? This is craziness. And it's like, yeah, that's craziness. That's bad architecture. Almost, there's hard to justify something like that. So that's one of the interesting, and I hadn't really thought about that before. It's an interesting insight that bad is easy to identify in architecture, but good is much harder. Because good is so subjective, whereas bad is a lot more objective.
Yeah. Then we can define good architecture as architecture that does what it needs to do and has a lack of deficiencies, right? Or lack of bad patterns or things that are truly
but
bad.
I would even say, I would add to that, adds value to the organization because none of them exist in a vacuum. So a pristine architecture that does the wrong thing is of no value.
Having that said, that the architecture smells and stuff like about bad architecture, is there such a thing or a process of architecture refactoring?
Oh, certainly. We actually make this distinction in our software architecture, the hard parts book, about software architecture refactoring versus migration. So the distinction I make is, so the technical definition of refactoring, and this is, Martin Fowler actually has a term called semantic diffusion, that when there's a technical term out in the world, it will gradually lose its distinct meaning. And refactoring has become a synonym for change because it sounds cooler than change. So your boss comes to you and said, would you refactor that, please? Rather than say, would you change that, please? Because it sounds cooler to say, would you refactor it? It sounds more technical. It sounds more like you're doing harder work. But we already have a word for change. It's the word change. Refactoring has a very distinct definition, which is to change the internal structure without changing the external behavior. So refactoring an architecture is doing exactly that, changing the internal structure of the architecture without changing the outward behavior. That would be a case of taking something like a monolithic architecture, a modular monolith, and just converting that into microservices. By breaking the components and building individual services from them, that's a refactoring of your architecture. What we see more often is a migration, which is both changing the architecture style and changing the internals as well at the same time. And one of the most common things we see is taking, when you think about a layered architecture with presentation, business, and presentation, the domain, the bounded context, is smeared across all those layers. Well, if you take that layered architecture and convert it to microservices, you're kind of turning the architecture inside out, because you're taking that thing that was smeared across layers and making it the top level thing, and then take those technical layers and layering them inside. So that's a migration, because you're doing both, changing the architecture characteristics, but you're changing the domain at the same time.
Yeah, absolutely. I agree with that. You know what sounds cooler than architecture refactoring? Architecture evolution. Could you talk a little bit about evolutionary architecture, please? What it is,
absolutely,
and like how it works.
Yep, absolutely. I'd be happy to. This was a great insight by Rebecca Parsons, who is the CTO of ThoughtWorks. And a lot of people don't know this about Rebecca. Back when I first joined ThoughtWorks, there was no CTO because it was such an opinionated organization. It was very small at that time, under 1,000 people. It was a very opinionated organization, and it was, you couldn't really imagine someone having enough respect to be the CTO, because it'd be arguments everywhere. But Rebecca at the time was working as an enterprise architect at ThoughtWorks and gained such a reputation that when they finally decided we need a CTO, they said, well, who could it possibly be? And pretty much everybody in the company said, oh, it should be Rebecca Parsons. And she has been the CTO ever since. But when she was still doing a lot of technical work as a consultant, she and I worked together on a project, and she started describing this approach to me that she had picked up. A lot of the great insights we get in software architectures, when you take somebody that has expertise in one technical field and plunk them down in front of a completely different problem and ask them for insights. A data mesh, which Zhamak Dehghani came up with, is exactly what happens when you take a distributed architecture expert and plunk her down in front of this difficult analytical data problem and say, hey, can you solve this? And turns out she can. Well, this is exactly what Rebecca did. She worked for a while in the evolutionary computing space and genetic algorithms, and this idea of a fitness function, which is a way to guide the way a genetic algorithm mutates. And when she started doing architecture consulting, she saw this great need to, so when you look at your problem domain, the thing that you're building the system for, how do we manage the evolution of that? We have a lot of mechanisms. We have unit tests, we have functional tests, we have user acceptance tests. If you're a big enough organization, you have an entire QA department that manages the evolution of your problem domain, but we don't have a similar mechanism for the capabilities of the system. That's all behavior, but what about performance and scalability and elasticity and security? Those capabilities, we also need a similar verification mechanism for. And Rebecca looked at that and said, oh, it's just like the fitness functions in genetic algorithms. And that's where she came up with this idea of an architecture fitness function, which is really the definition of the mechanics of evolutionary architecture. So there are two aspects of evolutionary architecture. What is the mechanics? How do you build safeguards of your architecture so that as you make changes to the architecture, you have safeguards in place so that you can keep making changes? That's this idea of architecture fitness functions, like unit tests for architecture, but broader, because they may be monitors or, who knows what, all kinds of mechanisms. And then the other part of evolution is thinking about how you structure architecture to allow you to structurally evolve, which has to do with modularity and coupling and that sort of stuff. She described this idea to me, and we actually used these techniques on clients for years, both she and I. And then at some point we started talking to Pat Qua about this, who was also at ThoughtWorks, and he got super interested in this. And then we decided to write a book about it, the first edition of which came out in 2017. And that was actually my 10th book which just came out in November of last year, which was the second edition of Building Evolutionary Architectures, because in the intervening years, we've seen that idea grow and grow, and the tools are getting better for this and the support for this idea. A lot of what's starting to drive interest, of course, as always, are things that are breaking that could have been prevented. Things like
Yeah.
there's a lot of concern about software supply chain issues now. Dependencies in software, what if they get affected? The Log4j problem was a big eye opener for a lot of organizations.
Yeah.
And so software supply chain and using automated tests for that is an architectural fitness function. And of course, that's one of the things that allows you to evolve a system, is having those protections in place to make sure that your capabilities don't break the same way your behavior doesn't break.
Yeah, perfectly makes sense. And it sounds to me like if we have a covered system with fitness functions, right, and covered every important piece of system entities we have, we can experiment within architecture. We can put some different things into production and see how they change those entities or in staging, right?
Absolutely. Well, and part of that is the ability to do like things like A/B testing, but also just what if games to say, I wonder if we cache everything locally, what would that do to our performance? Well, if you already have the performance fitness function in place, that's a trivial experiment. Whereas if you don't have that in place, well, we don't want to do that experiment because we'd have to figure out a way to measure our performance, pro and con. And so having the capability at hand encourages that kind of opportunistic experiment that you can do at a much faster feedback loop.
Yeah, and like I remember back in 2015, 2017, with the rise of microservices and article from Martin Fowler, there were some thoughts about disposable services or disposable architecture, when you can rewrite everything in 2 weeks, throw it out, and write another stuff and experiment. Do you think this thing of disposable architecture is still in place, or this term just faded away?
Well, it's really more perspective about, how do you want to spend your time building things? Part of the idea of a disposable architecture is have the pieces so small that they can, in fact, be thrown away. And some of the very early microservice projects were quite intentional on, well, let's just throw that away and build it from scratch rather than try to make major changes to it. And that's still a benefit of really highly decoupled microservice architectures. But I mean, how often do you really need to do that? You really need to do that in like super fast changing startups or pivoting or adding new capabilities. I mean, once you've reached a certain number of releases, I mean, how quickly does it change like that? So I think the aspiration is good to keep things extremely decoupled so you can break a piece off and replace it at some point in the future, which I think is the essence of that idea. And a lot of what drove that, I remember when that blog entry came out from Martin, a lot of what drove that was at the time, architectures were anti-disposable. There were no way to untangle the pieces from one another and throw part of it away. So I think it was part of leaning toward the encouragement of building more decoupled architectures.
Yeah, that's also interesting in a way that depending on the project size, we decide like whether it can be disposable or not, right? Let's say we are in an area of writing first version of a product or even MVP for the product, right? Proof of concept, something like that. What is the point when we need to start thinking about the architecture? Is there like such a thing in development? Okay, here I need to plan more because something,
Well,
I'm not sure.
so here's the analogy. Here's the analogy I commonly give because it's a question that comes up a lot. It really depends on the scale and the capabilities of the thing that you're trying to build. So my analogy is if I decide to build a doghouse, I don't have to have an architect to do that. I'll go to the store and buy some wood and bang it together and hey, it's going to be a pretty good doghouse. If I need to build a 15-story office building, I need architecture. I need electricity, I need plumbing, I need elevators, I need safety. I need an engineer to look at the safety of the thing. So let's think about building a little application to manage a kid's football team. I don't need an architecture for that. I need to download a framework and bang a few things together and I'm good. Think about an architecture that needs to support 1,500 simultaneous users because we're building an online auction. I can't just start building that. That's like just start building the 15-story office building saying, well, we'll just build enough onto it to eventually support 15 stories. No, you have to start with a foundation that will support the weight of 15 stories. For the same reason, if you're just trying to design a system that has unique capabilities, you need to start designing that up front, or you're going to end up rewriting it over and over and over and over again. One of the common tropes in the design world is that if you're trying to build a big lorry, a big transfer truck, you shouldn't start designing that. You should start with a roller skate, and then a bicycle, and then a car, and then a truck, and then a lorry. But you can't do that with architecture because a roller skate won't support as much weight as a lorry supports. The behavior looks similar, but the capabilities are vastly different. And architecture is about capabilities, not behavior. So there has to be some design up front. Now, what really distinguishes Agile from other kinds of architecture is we try to do as little design up front as possible and iterate on design. That's the key to agility. It's not no design up front. It's how fast can you get feedback and iterate on your design. And we're big proponents of trying to iterate on design and architecture. In fact, a big part of our software architecture, the hard parts book, are tools that allow you to create a candidate architecture. I don't know if it's perfect or not, but so let's apply some tools to it to see, can we change it in this way or that way, and see if we've made it better or worse when you do that.
Yeah, sure. And having that process of starting building architecture agile, delivering incremental changes to architecture, I'm thinking of Conway's law, which is always often mentioned, which states that software systems being designed tend to mirror organization communication structure. If we know that it will happen inevitably or not, this is a question. Will it inevitably happen or not? What's your experience with that? And should we try to mitigate that, or should we follow it?
Well, I think it's one of those forces because we're social creatures, and so it's a natural way. Dunbar's number is another similar kind of phenomenon that you can't really know more than 150 names and faces, and so a lot of organizations split themselves up around that number. Conway's law is the same thing. It's really just leaning into the natural proclivities of humans, the way that we tend to work with each other versus trying to create artificial distinction. So you can make it work if you want to really force it and fight it. I've seen organizations that have strict separation work well, but there's just a lot of overhead to make that work. So, it's the question of, do you want to make everybody in your organization walk 12 flights of stairs 15 times a day, or would you rather install elevators? They're both possible. Humans can do both those things. I think some people will be happier with an elevator than walking, 15 flights 12 times a day, but, it's still possible. So, and you could optimize it and, only hire super fit people and make them go work out. And so, if you really tried to optimize toward some sort of layered thing, you could, but, a lot of the interest around things like inverse Conway maneuver and a lot of the research that's coming around team topologies is really about this. Can we find ways that allow people to build complex things more easily? All the stuff around domain-driven design, we've been trying to do that forever, and that's really what domain-driven design and team topologies is. We're building these very complex things with lots of moving parts from scratch. How do we optimize that process in a way that's sustainable for a long period of time? So we keep trying.
It makes sense. And following this topic, you mentioned that people prefer simpler things sometimes. And in one of your talks on evolutionary architecture, I think you mentioned that sometimes software architects and development teams have different goals on a project, or at least conflicting goals. That when software architects wants to ensure that things are done right, and the dev team might aim for faster code delivery and feature delivery, right? And this leads to a tendency that they choose, or company choose, or the project manager choose simpler solution over better solutions to move faster, to be agile, and all that stuff. And in the end, following your analogy, you might not have a truck built once you finish it because you always tend to lean to simpler solutions. How to find a compromise, or how to communicate those things?
So that's a great question. One of the things that you can do is make the trade-off analysis better. So one of the things that we try to do at ThoughtWorks is that the architect doesn't work for the project manager. The project manager and the architect are peers. So the project manager can't just tell an architect, no, don't do it that way, do it this way because it'll be faster and compromise. It's more of a conversation that, okay, we really need to hit this release, but now I'll negotiate for some time to make that better later, because I think we can make a compelling argument that you can't build something sustainable if you keep compromising on the design every step of the way, or you keep just building hacks and building hacks and and eventually you're going to have something that's not sustainable. There's too much technical debt to actually get anything done. I've actually seen, this is another one of my consulting horror stories, but I did some work for a company for a while. They were in the process of trying to rewrite their core system, but their core system had finally reached a point where every morning they came in and they had 5 or 6 hours of fixing data synchronization issues and bugs and all that other stuff on the existing system, which gave them like an hour a day to work on the system to try to replace that thing. And they were almost at the point where it was a full-time job every day for every developer just to keep the thing alive, because it was so compromised, because it was so rushed, because it just never gets better. It just gets worse and worse and worse. And so I think that's the side effect. So, but you have to go into this always with your trade-off hat on. There are times when you need to compromise for a short period of time, but then work into the schedule. Let's figure out a way to mitigate that, because, and again, it depends on, back to your question of disposable architecture. My first question would be, if there's a huge amount of schedule pressure, and to back to the premise of your question, it's almost never the developers who are resisting doing the right thing. It's the project manager leaning on the developers to bypass the things the architect wants to do, because we want to get got to get this thing done. So very often the developers are in the lead because they want to build something that's high quality, but now they're forced to. So, building a way to mitigate that, and making the non-technical people realize what the sustainability of this thing is. First question I would ask the project manager when they start applying pressure like that is, how long do you want this system to last? Is it 2 years? Then yeah, pedal to the metal. Let's go. We'll just go like crazy. Toward the end of the life, it's going to be a nightmare to live with, but man, we're going to make great progress until we get there. But in 2 years, we're going to have to throw it away and flush it because it's going to be a pile of trash. Oh, you want to keep it for an indeterminate amount of time that you want. So we got to build some real structure into it, some protections, and pay attention to what we're trying to build.
Yeah, makes perfect sense. Thank you. I wanted to ask you about one of the terms you introduced in your book, The Hard Parts of Software Architecture, which is, I think you expected that question about the architecture quantum. Could you please explain what it is and how to use it in our communication?
It's a tricky concept, and I still don't think we've described it in prose extremely well. The closest thing to think of is, it's just like the idea of a bounded context from domain-driven design, but in architectural terms instead of domain-driven design terms. And we thought about just calling it bounded context, but then the problem is it's not exactly that, because it has way more nuance than just bounded context. And bounded context is a logical construct. An architecture quantum is a physical manifestation. And what we've realized over time, because we've been leaning into this concept, and in fact, the Software Architecture, the Hard Parts book really pulls this apart more. An architecture quantum is a way to think about the scope of things in software architecture. So it is the scope of a set of architecture characteristics, which means that it's a way to analyze both kinds of important coupling in software architecture: static and dynamic. Static coupling are the dependencies and how things are wired together in a software architecture. And so if you're wired, all 4 of these things are wired to the same database, that's a single architectural quantum. Because a way to think about this is, if I were trying to make this more scalable, what would the bottleneck be? They're all talking to the same data. That's going to be the bottleneck. So they have to share the scalability characteristic amongst all those services, because that's the choke point for scalability. So it's a way of analyzing coupling, of how things are coupled together and how they form scopes for architecture characteristics. It's really about the granularity of services in a microservice architecture. That's the static coupling of those services in an architecture. The dynamic coupling is, once you've figured out those things, what the granularity of your services are, what happens when they need to start communicating with each other. And we figured out that there are at least three things you have to think about all the time. Communication, which is it synchronous or asynchronous communication. Consistency, is it atomic or eventually consistent? In coordination, or we're using orchestration, or we're using choreography. And that, of course, leads to the combination of all those things, which is this idea of transactional workflows or sagas. So that's dynamic coupling. So the quantum idea really suffuses all of that, because the quantum really is the service granularity, its dependencies, which is static coupling, and then how it interacts with other services, which is the idea of dynamic coupling.
Yeah, thank you for this explanation. And also I wanted to say that 3D dimensional space that you mentioned in the book, like with communication, which type of communication we have, consistency and choreography, right? So it was eye-opening, I think. Nobody before put it that way, that this is actually a space problem. Very smart idea, and thank you very much for that. And yeah, thanks for explaining architecture quantum. I wanted to dive into a little bit into infrastructure topics maybe. And because like 10 years ago, I think clouds were not the thing, right? There were Amazon Cloud maybe starting out, and there were discussions whether it is safe to store data in the cloud, whether you can trust clouds as banks and put your data there, if you put money into a bank, something like that. I remember those analogies.
Yeah, changed all that for everybody? Salesforce. Before Salesforce, nobody would ever give up that kind of info. And then Salesforce came along. It's like, oh, it's so convenient. Yeah, we'll do
that. I didn't know about that. But this leads me to a question: how like modern DevOps influence software architecture, and should the architect plan or like, I don't know, lay out the infrastructure for the project, or what clouds to use, what services in those clouds to use, and all that kind of stuff?
Absolutely, it has a huge influence. In fact, the way new architectures come along is depending on new capabilities arriving in the ecosystem. So one of the kind of humorous what ifs I play is, imagine that you're a software architect and you hop into a time machine and go back to the year 2001. And you go to the head of operations in your company and say, hey, I've got this great idea, this new kind of architecture called microservices. We're going to take each capability in our architecture and deploy it in its own service with its own database, really decoupled. We can change stuff really fast. It's going to be awesome. So I'm going to need you to go to Dell and order me 50 new servers, and I'm going to need 50 new Windows licenses and 50 new Oracle licenses, and you're going to get kicked out of that operation room as fast as possible. You could not build microservices on that kind of commercial ecosystem. It took Linux becoming good enough for enterprises to trust, and then enterprises trusting it, and then things like Puppet and Chef coming along. But what happens, and this is exactly how things like microservices come along, is, there's no ivory tower where a bunch of architects get together and go, what's going to be the next big thing in software architecture? What happens is new capabilities slowly come up, and clever architects look and go, hey, if I took two of those and wired it up with one of those and stuck one of those on it, that would solve a big problem we've always had. Let's do that. And enough people do that, and somebody else says, hey, they took the two things and put it on the thing, and before long, it's like, we got to give it a better name. Let's call it microservices. That's how these new things come up. They're not predetermined. It's a reaction to the kind of things that exist. And microservices is absolutely a reaction to continuous delivery, that kind of automated engineering practices, the DevOps world, Puppet and Chef. I would argue that microservices could not exist without tools like Puppet and Chef and on-demand infrastructure, etc. And so every time there are new capabilities like that, new architectures come up because clever people figure out ways to take advantage of that and build new things on top of it. So you can never separate these things. They're all synergistically entwined together, and much worse than it used to be. I can remember a time when architects didn't care anything about operations. Operations was a giant black box. The only thing you cared about operations was you would request resources from operations. I need a server within the next 3 weeks, and then 9 months later, you'd get that server. That was operations in most organizations at that time. But now there has to be a much tighter work with operations because of on-demand infrastructure and cloud and the architectures like microservices that require a lot more integration. But we get more capabilities as we combine those things. So I think it's inevitable, and I think the cloud is going to continue to change the way we think about architecture. So let me give you a fantastic example of that, the best example I've heard, in fact. And I would love to take credit for this, but I cannot. This is from the great, great Dave Farley, who I had the privilege, I host a podcast. I'm the sometimes host of the ThoughtWorks Technology Podcast. We had the privilege of interviewing Dave back in December on the podcast. And he talked about, so Dave is well known for one of the co-authors of the Continuous Delivery book, but he's also well known for designing the LMAX architecture, LMAX. There's a write-up on Martin Fowler's website about it. It's this amazing architecture they designed where in the early 2000s, they managed to achieve 6 million transactions per second on a single Java thread, using this architecture called an input disruptor. It's incredible still to this day that they managed to do that. But and it's a lot of tricks like making the bytecode so small it fits inside the CPU's cache. But they coined this term mechanical sympathy. The way they ultimately created that was understand how every piece of the CPU worked and how that interacted with the bytecode to optimize every bit of that. And so my co-host on the podcast, Mike Mason, asked Dave, so in this land of cloud, does mechanical sympathy even make sense anymore? Or what is mechanical sympathy for the cloud? And Dave said something that is so smart because it gets to one of our fundamental weaknesses as architects, which is some assumptions are baked in so hard we can't even see them anymore. And this is Dave's great example. Since time began, storage has been expensive and CPU has been cheap, which is why we normalize data. We normalize data because storing it all is too expensive, and we can use CPU to break it up and then link it back together in relational databases. But in the cloud, the opposite is true. Data at rest in the cloud is essentially free. It's moving it around and shuffling it that costs money. And so your instinct as an architect is always normalize your data. In the cloud, you should not. You should duplicate it and shard it all over the place because once it's at rest, it's essentially free. Dave tells a story of a friend of his who runs a website that's backed by an Amazon bucket, basically. He has 100,000 unique visitors a month, and he pays like $2 to Amazon for hosting fees because it's all just sharded and available, and he doesn't have to move it around or anything. That's the fundamental kind of shift that happens when you moved from something like on-prem to cloud. You have to rethink some deep fundamental things about how you think about data and how you organize it. And of course, that changes the way you think about getting to it and accessing it. So, but I feel fully confident that after the cloud will come the next thing. I don't know what that next thing is going to be, but I feel fully confident that it will show up because it always has so far. So whether it's going to be quantum computing or, transporters or flying cars, I don't know, but there'll be something else that is, changes and shuffles all of our trade-offs again.
Yeah, the example is brilliant. Thank you for sharing it. Yeah, that's so true.
Well, that's very typical of
the,
Dave Farley. You know, he's the easiest podcast guest ever because all you really have to do is say, "Hey, Dave, how is things going?" and he'll just say interesting things for like an hour or so. He's the perfect guest.
yep, agreed. Uh, I wanted to talk a little bit about the second law of software architecture when the why is more important than how, because this leads me to a topic of software documentation and architecture documentation. I know this question might be abstract. I'll try to narrow it down. So the question is, what is the sufficient level of architectural documentation for a project? Or are there any essential or key architectural artifacts every project should have?
That's a great question. And I'll turn that back on you. What artifacts would you or one of your team members find useful in the future to influence a future decision by understanding what led to a past decision? That's ultimately what any kind of documentation like this is for. We really tout this idea of ADRs. They originally called lightweight ADRs, because some organizations get carried away with this documentation, create these big giant templates and wikis and that kind of stuff. But so it's been my experience that it is often easier to get people to write documentation than refer to it later. You'll write it up because you're proud of, hey, I made this decision and it got approved and all that sort of, but then going back to that later, that's the key, and that making it very simple and findable is the real key here. So the real question is, what will a future self of mine find useful? Because when you undertake an architecture decision, by definition, you're evaluating a bunch of trade-offs against the current landscape of your architecture, what it currently does, what we think it needs to do in the future. And you're doing a fair amount of analysis work. And if you're really good, you're doing measuring things and learning and getting hard facts to inform that decision. It's a shame for you to take all that data and just let it entropy into the universe. Because a year from now, oh no, we have this brand new capability. We've got to revisit that decision. It's really incredibly beneficial to get back in that headspace, the mind space of what did the world look like when we made this decision and went down this path, because now we have to take a different path. What did we think about then? Did we realize that then? What are the things that we thought about then that, oh, we should probably think about now that, we don't have to redo that analysis? So that's the real value of documenting a decision like that and why you chose that decision. That's why we like ADR so much. They're text, so they're easily searchable, and they are literally the smallest amount of info you can put in something to make it discoverable, rather than going, trying to overly document or overly, be verbose with your decisions about things. Frankly, as much as I try to do that on projects, the biggest challenge I've seen with clients is not creating them, it's actually making use of them. It's still a struggle in most organizations. I've seen a few that do it well. And in fact, I think so. Here's the challenge for all the people who are attending this: document your architecture decisions like that, but then figure out a way in your organization to incentivize the reuse of that. Just asking people to do it is not enough. You have to figure out an incentive for doing that. So maybe there's some sort of reward structure. Excuse me, pollen is terrible here this time of year in Atlanta. You need some sort of a reward structure that says, if you usefully reuse this, then some benefit accrues. You get points that lead to an extra vacation day, or you get a bonus, or you get free soda, whatever it is, some incentive to actually encourage people to do it, because that's the way to, actually get somebody to reuse something like that. And a lot of times it's a challenge to find the right level of granularity, and it's very organization dependent. So if there's some things, so for example, if you're in a business that's highly regulated, I would definitely put a section in your ADR about what regulatory considerations I had to make for this decision. And that would be immensely useful at some point in the future. So it really is driven by what's the minimum amount of information that is useful, and then just try to be as succinct as possible.
Sure. And yeah, I definitely agree about the value of IDRs. But I also wanted to ask about any standardization of a documentation. We don't have many ISOs or standards on documentation. We have 42010 about software documentation description. UML didn't work to my understanding because everybody leaned towards C4 model from Simon Brown, right? But do you see a practical implications of things like software architecture documents that Carnegie Mellon Institute, Software Engineering Institute mentioned in their Views and Beyond book, or ISO standards or something like that? Do you see that applied on a project, or this is just a rudimentary thing?
The problem with trying to create a standard like that is tell me what standard makes sense for someone who's designing embedded software for a soda machine versus someone who's building Amazon.com.
It is different. You have a lot of optional questions, right? Yes.
Yeah, it's just too different. And the context is always, so any kind of, there was an attempt to standardize architecture characteristics or non-functional requirements at one time, but it's a ridiculously incomplete list because we keep inventing new ones. I keep going back to the value of the organization. Even things like, so Mark and I have long resisted using C4 or Archimate and certainly UML in favor of just ad hoc diagrams when we create documentation for something in architecture. ThoughtWorks uses Mural, which is the online drawing tool, which I use a lot for that kind of documentation. Because the problem you run into with any kind of standard like that is, okay, now I'm trying to do something there's not a standard icon for. Okay, I have to build a new icon for it to support that. Okay, now it's not a standard anymore. Great. Okay, well, that's fine. I'll customize it, but now a new version of the standard comes out. Oh, look, they have an icon for that thing now. Okay, so do I, you can see exactly. So it's never a standard because you almost instantly have to customize it for something you need to make sense. And so it never stays a standard for any amount of time. Having said that, there is some interest in adopting something like Archi, which is pretty flexible, or C4 is pretty flexible, so that you can get assistive AI to parse it and tell you things about it. That is potentially interesting. They can't do that yet because there's no logic behind these things. It's just language processing. But if they can understand and describe it, an architecture, give it a diagram and describe it to me in text and describe some of the limitations and capabilities. So for example, if it noticed everything coupled around a single database, it can make some predictions about, hey, this is not going to be scalable. So, that kind of, so there's some benefit there of having some standard enough that an AI can parse. So we are thinking about softening our stance on standards like that, but you're still going to end up, creating custom things, and then the custom thing, your parse is not going to understand your AI engine, so you're back to the same problem.
Yeah, it makes perfect sense. Neal, a quick question about your time. Do we have a hard stop in 2 minutes, or we can have it longer, maybe 5-10 minutes?
Yeah, well, I don't have a hard stop in 2 minutes.
Thank you. So I'll ask a couple of more questions because I have a bunch of them, and really exciting to talk with you. So thank you very much for this.
Sure.
I wanted to ask a little bit about microservices, because it was a hot topic for a while, and I wanted to ask, are this still a thing, or we are in post-microservices era?
I don't think we're anywhere near post-microservices. In fact, I would even say, so you're familiar with the Gartner adoption curve, where the hype cycle, which things are really hyped, and then it enters into this thing called the trough of disillusionment, and then it evens out into the kind of the plateau of usability. I'm paraphrasing those terms. I don't know that microservices, either they skip the trough of disillusionment for the most part, or if we haven't gotten there yet. So Martin and James first started talking about microservices 10 years ago. So one of the things that I look for in software architecture are fads versus trends. Do you remember Ajax?
Of course.
Ajax was all the rage for 2 years, and then it faded away and got eaten by other technology. That was a fad. Microservices is a trend, and vendors look hard at this too, because you don't want to invest a lot of time and money in things that are fads, But you do want to invest heavily in trends because that's the direction the market's going. And for me, microservices looks like a huge trend for exactly the reason that we're not choosing it because it's stylish. We're choosing it because it solves real problems for a lot of situations. When you need that kind of scale, you need that kind of decoupling, that kind of agility, the things that microservices deliver, it delivers extremely well. And it also builds an architecture that allows you to evolve over time because it discourages the kind of coupling that damages your ability to evolve slowly and incrementally over time. So I think that's why we still see it a lot. We still see a lot of demand for it. Most of our default new projects are probably microservices of some flavor or another, or distributed architecture like that. So I think it's just effective for solving a lot of problems. So I think that's where it's going. It may morph and change over time. I think that the hype around serverless, to me, it seems like what has cooled down, because when it first came out of the gate, it was going to solve all of computing ills. And now it has definitely calmed way down as people have rightly discovered it's great for some things, but it's less effective for other things. And so, that to me has had more of the kind of hype cycle stuff that microservices has.
Talking about trends and serverless, I'm glad that you mentioned that, because there is another trend. I'm not sure how it's on your side of the globe, but here everybody talks about no-code, low-code solutions that they will replace developers again. People will go and do their business processes in the cloud, just dragging and dropping boxes and lines and connecting them together. What do you think about that? Do you think they will replace developers and architects
Snake
with
oil.
no-code and low-code solutions?
About snake oil. It's not true. It's marketing hype. About every 5 years, some version of this rears its head and we have to go beat it back down again. If it were that effective, every single company on earth would be using it because there'd be no reason to use anything else. Do you remember the 4GLs? Delphi,
Yep.
Power Builder, Visual Basic, Paradox, DBase for
Great
Windows.
tools, by the way.
Great tools. I notice you're not using them now, are you? Because
No,
they suffered from the exact same thing that any low-code or no-code environment. We define this in the Evolutionary Architecture book, this last 10% trap. They're great for building simple things, but then you reach a point where I can't build anything more sophisticated than a toy. And then you just have to abandon it because you can't get far enough underneath the abstraction to actually build the thing you want to build. And so these things demo great, but then they always reach a point. So here's the advice I give for low code, no code stuff. Don't not use them. Use them cautiously. But typically what you do when you pick up a new platform is you do hello world to see what it does, just to see if you can get it to work. If you can't get a low code, no code environment to work, then why are you even looking at it? What you need to do is find the places it's going to break. Those are the spikes you need to do with the low code, no code. What are the things that are going to push it to its limit to find out, can I live with this limit? Because I guarantee you that low code, no code thing will not do every single thing you want it to do. You need to figure out the things that it won't do, and can you live with that? If you can, then it's a great choice, because the things that you need, you can build really fast. But you don't want to be in a place where we've now spent 2 years building this thing and, oh, it won't do that. And we really need it to do that. Then you've wasted 2 years and you got to start over. So that's the thing you're trying to avoid.
Yeah, and you actually predicted one of my questions easily at the beginning of this talk about the AI in architecture and large language models and that hype about ChatGPT. So, as you know, ChatGPT can write code. What's the future of it? Again, will we have more AI tools? Have you tried any of them, Copilot from GitHub or anything like that? Do you think it'll be a useful tool for developers or even architects? Can it suggest an architecture, for example?
So it can suggest an architecture. It is mostly wrong because it can't do trade-off analysis. It can give you an answer that's statistically likely, which is all it is, but but there's no logic behind it. So here's my analogy for AI and the current AI stuff. They are tools. So back in 1970, accountants spent most of their day recalculating paper spreadsheets by hand with calculators or adding machines. That's why when VisiCalc on the Apple II came out, this first spreadsheet, they literally went to the computer store and said, I want the VisiCalc software and whatever computer it runs on. I don't care what it is. I don't care if it gives me radiation poisoning. That is the most useful thing I've ever seen in my life. And instantly, accountants became much, much more productive. And they could build much more complex spreadsheets and model much more complex financial things. And by 1980, if you were an accountant who didn't know how to use a spreadsheet, you had a hard time finding a job. That's exactly what AI tools are for developers right now. It's knowledge, but not wisdom. You'll never have to wonder about how to configure Kubernetes again because AI knows how to configure Kubernetes. What AI can't tell you is should you use Kubernetes or not. It's knowledge versus wisdom. But that's important because that's the way to use these tools. So I've used a variety of these tools. A lot of them, like LangChain, is an open source tool that has all these plugins for things like I will take English language or some spoken language and generate and execute a SQL statement for you. That's fantastically productive for a developer who is not super sure about SQL, and you still have to check what it generates, but man, that's much better than banging it together by hand and getting syntax errors and that kind of stuff. So learning how to leverage these things, I think, is important. And there are a lot of tools. So many of you are familiar with the ThoughtWorks Technology Radar. The next edition is going to come out toward the end of this month, and we have a whole bunch of AI-assisted software development tools on it. And in fact, that's one of the themes. So part of your job as a software developer and architect now is find the tools that give you faster access to knowledge so you can apply wisdom, because that's really the sweet spot of your job. It's not figuring out how to configure stuff. It's figuring out should we use this stuff or not. And so using the tools like that to help you get to decision points, I think, is a great use of them.
Talking about wisdom, I want to transition into a book sections. And we already have from you Fundamentals of Software Architecture book, the hard parts of software architecture. Would we have like a more advanced maybe book, something like spooky parts of software architecture, shady parts of software architecture? I don't know. You mentioned you're working on the head first system architecture or software architecture book, right? Yep. Are you planning to transition maybe at third level into that series of fundamentals, the hard parts?
We are. Mark and I are always working on what we refer to as book.next. But the way that we build books is iteratively. So when we started Software Architecture, the hard parts, we didn't actually know what was going to be in that book. We just knew there were a lot of topics that were difficult and interesting, and we wanted to investigate why. So we started teaching that material, doing workshops, online classes, etc. And we iterated that material into a book. I write books iteratively. Books are not big, giant waterfall projects. You start with a seed of an idea, and then you start talking about it and seeing what works and what doesn't work and ways to describe it. And that's exactly how we got to Software Architecture, the hard parts. We started iterating on new material. And this material right now, in its infant stage, concerns a lot of integration architecture concerns and a lot of enterprise architecture concerns. We want to reform enterprise architecture because it is one of the roles that makes the least sense. If you look at the previous century thinking about enterprise architecture, all the things they used to do make no sense anymore. And so we want to do enterprise architecture for the 21st century. There's a lot of stuff about team topologies and integration architecture. So that's what it is so far. I don't know what it's going to be, but after we finish Headfirst Software Architecture, which is going to be before too long, then we're going to embark on book.next. And so about 2 years later, we'll have, it probably won't be software architecture, the harder parts or the hardest parts. No, we're not sure what it's going to be called yet, but it will be conceptually in that same series. In many ways, Headfirst Software Architecture goes in front of Fundamentals because it's a good on-ramp to the fundamentals book. And then this one will be more advanced topics, but higher levels in architecture than the hard parts book. At least that's the current plan.
Sounds very exciting. I'm really keen to forward to see that book and read that book.
Me too.
And glad to hear that. That raises the chance to that book to be published and completed. So yeah, sounds perfect. I wanted to ask, what's on your bookshelf? What recommended books for software architects or things you can recommend, apart from the ones from you've written with Mark and other co-authors?
I don't read a lot of software architecture books. I do a fair number of online classes on the O'Reilly platform. The Flow Architectures book is quite interesting, which is an O'Reilly book. Gregor Hope's Architect Elevator is a fantastic book if you haven't read it. It actually covers some of the material we're thinking about for our next book, which is talking about all these different levels of architecture and communicating between all those. And that metaphor of Architect Elevator is really great. I've been looking at Head First books a lot lately, and Head First Git by our co-author Raju Gandhi is just so good because, Git, the internals of Git are actually pretty complicated. And so having somebody walk you through the internals and how that stuff works in a Head First way, it's a perfect subject matter for Head First. So it's one of the better Head First books I've seen. So that one is definitely highly recommended.
Yeah, internals of Git is fascinating for sure. Like the snapshots work, the diffs work, how they try to diff from the very beginning of the project, then shifted to reverse diff from the current point to the beginning. Yeah, that's awesome topic to discuss and a lot of challenges to implement. That's true. Mm-hmm. You mentioned you're working or released Radar from ThoughtWorks recently, right?
Mm-hmm.
Or soon?
It'll be out at the end of this month. We've done the work on it, perfect. And it's been through translations and all that stuff now. So coming soon.
Can we get a preview maybe? Like what's emergent trends in architecture, or maybe like what's up to date? Can you name a few?
Well, so all the AI assisted software development. So for the first time ever in our radar, we had to create an outside visualization to kind of understand the categories and the overlaps and all that sort of stuff for the AI tools. The themes on this radar were AI assisted software development, of course, because that showed up a lot. We've also seen a bunch of new ways of trying to measure productivity that make sense. So there have been a terrible number of ways to measure productivity in the past, like, lines of code and, all the different. So there are a whole batch of new tools that measure things like how long can developers stay in flow state? Well, that's actually a useful measure of productivity. How little do they get interrupted? That kind of stuff. So we have a theme about how productive is measuring productivity, and there's some new thinking about that, which is really nice. We also have a theme about the how many large language models there are. You always hear about OpenAI and ChatGPT, but every large organization has a large language model now, and there are several are quite prominent, and each of them give you different capabilities and different training sets. And so we have a theme about that. In particular, some of the things like lane chain, which allow you to plug into large language models to produce specific things, like infrastructure code. Like there's a Terraform plugin that allows you to describe the architecture you want, and it'll generate Terraform forward to create that Terraform code to create that architecture. That's immensely useful. Things like there's a whole family of prompt engineering tools. So crafting the right prompt to get the AI to do the thing you want is a specialized skill. There are a bunch of tools that let you save prompts and tweak them and refactor your prompts so you can get consistent results. So there's a whole family of tools like that. So a lot of interesting stuff like that on the radar, particularly around AI stuff.
Yeah, looking forward to see it. Thank you for doing it. I think it's a super important tool and a very useful tool to discover new things, regularly checking it. So I love it. Thank you for it.
It's the only thing I know of that's purely crowdsourced from real project work. So there's no way to get on it except to be useful and loved on a ThoughtWorks project. So it's a unique perspective on technology.
Definitely invaluable. Definitely. Thank you. I think we could easily spend a couple more hours talking about different aspects of software architecture. The team and audience and I are very grateful to you for today's sessions and your time speaking about all the stuff about software architecture field. I hope someday you'll visit Ukraine whenever it becomes possible, and we'll meet on our offline events. Do you have anything in closing to say or something like that for
Nope. Thanks
community?
very much for having me. I was actually scheduled to come to Ukraine before the pandemic happened, so circumstances since then have prevented me, but I'd love to come there. I've heard great things about it. My friend Venkat Subramaniam raves about it there, so I can't wait to be there. And hope you have a great remainder of your conference, and thanks for having me. It was a great pleasure.
Thank you so much for this Q&A session, and have a wonderful day today.
Thanks. You too.